Hello everyone! There are movies, books and video games of the genre of science fiction that portray trips through black holes. It is said that black holes work as wormholes, that is, as portals that lead to distant areas of the universe. Is this really possible? And what exactly is in the center of a black hole? Guys, welcome to our channel. Watching this, you will understand everything about it. So, it's time to start our video. Wormhole in the outer space. Why so much expectation? First, let's talk a little more about the concepts of wormhole and black hole. Although we have already addressed these themes in previous videos here on our channel, as it has been a long time, let's review them here anyway. You all probably know that our dear Einstein put an end to the idea of traveling faster than light. According to the theory of relativity, objects with mass cannot move through space at a speed greater than the speed of light. But why? This is very simple. According to the laws of physics, the faster an object moves, the slower time passes for this object. When you reach the speed of light, the time for the object becomes zero. In other words, it stops completely. This contradicts the fundamental ideas about the nature of time. In addition, for an object with mass, it is impossible to reach the speed of light. Simplifying complex calculations, as the speed approaches the speed of light, called relativistic speed, the mass of the object begins to increase. And as the speed increases, the mass also increases, reaching infinity at the speed of light. According to Einstein's theory, due to compatibility between mass and energy, for an object to reach the speed of light, it would be necessary to provide an infinite amount of energy. However, this is absurd. Let's assume that we burn the entire observable universe with a 100% energy efficiency motor. We would certainly get an immense amount of energy, but even so, there is a limit to this. It would not be enough. In addition, the space is immensely vast. To travel the abyss that extends between the Sun and the closest star, Proxima Centauri, it would take more than 4 years even for light. A spaceship traveling at 90% of the speed of light would take even longer. For example, even traveling at this speed for thousands of years, we would not be able to leave the Milky Way. Considering this, we can lose motivation. In addition, it is worth remembering that this does not pass one among countless galaxies. For a long time, humanity dreamed of reaching distant stars and galaxies. Therefore, there are many people who are not satisfied with Einstein's axiom. We cannot deny this axiom. There is a lot of evidence that proves the veracity of the theory of relativity, and without this theory, all of today's physics would crumble like a building without windows. But what if it were possible to circumvent this? What if it were possible to circumvent Einstein's axiom? There are many indirect data that indicate a high probability that this universe has a kind of torsion. This means that we can cross space. Imagine a sheet of paper. There are 2 points drawn on this sheet. Let's assume that we need to pass a needle from one point to the other. Then it is possible to fold the paper and stick the needle in one of the points, causing it to come out through the other point. It is evident that the second way is easier. In addition, it requires a distance smaller than the real distance between the points drawn on the surface of the paper. If we consider that the galaxy of Andromeda is 2 million light-years away, finding a wormhole that takes us there would be a shortcut that would allow us to travel a distance that is perfectly viable within our reach. For example, if we could reach 2 to 3 astronomical units, even with the level of today's technology, it would already be a viable distance. Isn't it fascinating? Is there a wormhole inside a black hole? The existence of wormholes is incorporated into our view of the universe and astrophysics. But in reality, no such object has been discovered. It is possible that they have been found, but perhaps they are being recognized as black holes or something similar. The possibility of the existence of such large mass objects that not even light can escape was suggested in the 19th century. However, the conception of black holes closer to what we understand today was not presented in the 20th century. In fact, here the mass itself is not relevant. It is known that there are stars much more massive and bright than black holes with medium stellar mass. In black holes, all this mass focuses on a single point, literally crushing the space and creating a kind of hole. Nothing can escape this hole. Not even light is possible. Due to the hypothetical structural similarity between wormholes and black holes, the idea arose that they could be the same thing already in the mid-20th century. However, in this case, the wormholes would work only in one direction. This is because once something enters a black hole, it can no longer leave it. But if there is an entrance, there must be an exit, right? The so-called opposite behavior of black holes, in which they would expel everything without absorbing anything, has been called by scientists white holes. If we consider that the entrance to a wormhole is a black hole and the exit is a white hole, it would be logical to think that each black hole has a corresponding pair. In other words, there must be exactly the same number of white holes that exist in black holes. When the quasars were discovered, scientists thought they could be the white holes. However, unfortunately, later research showed that the white holes have nothing to do with it. Quasars are active galactic nuclei that are very far from Earth, and it was discovered that what we are seeing are their forms in initial stages that occurred more than 10 billion years ago. Scientists today believe that white holes do not exist or that they disappear soon after they form. In 2006, an event was detected of long-lasting gamma-ray eruptions called GRB 060614 in a distant galaxy towards the constellation Indus. Normally, long-lasting gamma-ray eruptions with more than 2 seconds are generated by supernova explosions that result in the collapse of black holes or neutron stars. GRB 060614 lasted more than 100 seconds, but no supernova associated with it was detected. The true identity of this gamma-ray eruption is still a mystery, but there are people who speculate that it could have been a white hole that formed and disappeared quickly. It is extremely difficult to investigate its internal structure. As mentioned earlier, anything that goes beyond the event horizon of a black hole cannot escape it. However, according to existing mathematical models, a black hole seen from the inside looks like a spherical hole open in three-dimensional space where all the mass of the black hole is concentrated. However, unfortunately, this model does not include tunnels. However, according to recent research, there is still hope. That is, at least some of the black holes could be wormholes. More precisely, they can be wormholes that are being mistakenly identified as black holes. These studies point to some peculiarities in the behavior of celestial bodies that we consider black holes. However, they claim that more data is needed to determine whether this hypothesis is correct or not. And so we end our video today. Thank you all for watching. We hope you enjoyed this content. Summarizing what we have discussed so far, black holes are probably not related. No matter what science fiction writers say, these two celestial bodies are completely different. However, there is a reasonable possibility that some of the black holes are actually wormholes. However, it seems that we cannot use these objects to explore the universe. There is no object that seems to be a black hole in the middle of a ray of 1,000 light-years from Earth. Therefore, to bypass the limitations of the speed of light and reach at least near Centauri, it will be necessary to look for other means. Still, let's keep hope and continue our search, right? We still have a lot of interesting topics to discuss, so please keep following us here on the Wikivedia Plus channel. A big hug and until our next content, guys. Bye!